Theorem: the characteristics vectors corresponding to a distinct characteristics value of a self-adjoint operator are orthogonal. Proof: let C1 and C2 be the two characteristics values of a self-adjoint operator T, and x1 x2 be the corresponding characteristics vectors, so that Tx1 equals to C1x1 and Tx2 equals to C2x2 by the definition of characteristics vectors where C1 and C2 are real. We shall prove that x1 and x2 are orthogonal, that is x1 x2 equals to 0. C1 x1 x2 equals to C1 x1 x2 equals to T x1 x2 equals to x1 T star x2 by the definition of the operator equals to x1 T x2 as T star equals to T equals to x1 cx2 equals to c2 bar x1 x2 equals to c2 x1 x2 because c2 is real, so c2 bar equals to c2. So C1 x1 x2 equals to C2 x1 x2 or C1 x2 x1 x2 minus C2 x1 x2 equals to 0. Or C1 minus C2 x1 x2 equal to 0, since C1 and C2 are distinct, so x1 and x2 equal to 0, which implies x1 perpendicular to x2 or x1 and x2 are orthogonal.